Imagine strapping yourself into the ultimate machine, a spaceship capable of something humanity has only dreamed of, accelerating endlessly, pushing the very boundaries of physics, and chasing the cosmic speed limit. What exactly would you see if you looked out the window as you approach the speed of light? Will the stars blur into lines like in the movies? Or is the reality of our universe far stranger and perhaps far more terrifying? Today, we are going to embark on a mind-bending journey. We'll push past the limits of optical illusions, dive deep into the very fabric of space and time, and uncover the shocking truth about interstellar travel. Strap in, because our engines are igniting. Our spacecraft is off, leaving Earth in the dust. We are accelerating constantly. Now, you might think going millions of miles an hour would crush your body, but here's a wild fact. Speed itself is entirely invisible to human senses. Just like sitting in a smooth, high-speed train with the blinds closed, you can't feel velocity, you only feel acceleration. As long as our thrusters push us gently, the ride is perfectly comfortable. However, space isn't empty. At these extreme speeds, a tiny speck of dust hitting our hull would hit with the explosive force of a nuclear bomb. Thankfully, our ship is wrapped in a state-of-the-art electromagnetic deflector shield. With our safety guaranteed, we gaze out the front window. But wait! The stars aren't doing what we expected. Instead of zipping past us, the sky is warping. As we speed up, a bizarre optical illusion takes over. The stars in front of us appear to bunch together, pulling away from the edges of our vision. Why? Think of driving through a rainstorm. The rain falls straight down, but as your car speeds up, the drops smash into your front windshield. It looks like the rain is shooting directly at your face. In space, this is called the aberration of light. Because we are moving so fast, the starlight racing toward us seems to change direction, coming entirely from the front. Behind us, the universe is expanding into a vast, pitch-black void, but directly ahead, a blinding cluster of stars is gathering. And if we look at the cosmic grid of space itself, straight lines begin to severely bend and curve. But what happens to the colors of these stars? Just like a police siren changes pitch as it speeds past you, light changes color depending on your speed. This is the Doppler effect. Looking back at Earth, the light takes longer and longer to reach us. Earth slowly fades into a deep, ghostly red. And if we zoomed in with a telescope, we'd see humanity moving in extreme slow motion. But looking forward, the stars turn a fierce, piercing blue. In fact, it gets incredibly dangerous. As we go faster, that harmless visible starlight gets compressed so tightly that it shifts completely out of the visible spectrum, turning into lethal, high-energy X-rays and gamma rays. If our shields fail now, we'd be instantly vaporized by the sheer radiation of the cosmos. Months pass. We are now traveling at a significant fraction of the speed of light. The optical illusions are gone. Reality itself is breaking. Welcome to special relativity. Our timeline has officially severed from the timeline of Earth. This is known as time dilation. It's the heart of the famous twin paradox. Because we're slicing through space so rapidly, we are barely moving through time. We are aging gracefully, eating breakfast and playing games, while centuries are burning away back home. Everyone we ever knew, everyone who waved goodbye at the launch pad, has already faded into history. We are entirely alone, surfing the edge of the future, locked inside a time machine of our own making. But here is the incredible reward for our sacrifice: length contraction. From our perspective inside the ship, the entire universe is physically squashing down like a cosmic pancake in our direction of travel. People on Earth think it will take us thousands of years to reach a distant star, but to us, the distance literally shrinks. We cross immense galactic voids in what feels like mere minutes or seconds. Visually, if we fly past a planet, it won't just look squished. Because light takes time to travel from the back of the planet to our eyes, the planet will actually look twisted and rotated. This wild visual glitch is called Penrose rotation. We are kings of the cosmos, leaping across the Milky Way in the blink of an eye. So, let's push the throttle to max. Let's hit the speed of light. But wait, the engines are roaring. We are burning fuel, but we aren't reaching it. Why? Here is the most brutal twist of the universe. You can never reach the speed of light. As you push closer to the ultimate speed limit, the energy you spend doesn't make you faster. It converts into mass. You become infinitely heavy, requiring an infinite amount of fuel just to move a fraction of a percent faster. No matter how hard we try, light always escapes us at the exact same speed. Instead of breaking the barrier, our entire field of vision collapses into a single, infinitely bright, blinding halo of light directly in front of us, surrounded by absolute total darkness. We are trapped in an unbreakable cosmic cage. Is this the end of our dream? Not quite. Space itself has no speed limit. Enter general relativity. What if, instead of moving our ship through space, we move space around our ship? Theoretical physicists call this the Alcubierre warp drive. By using exotic hypothetical negative mass, we could compress the fabric of space-time in front of us and expand behind us. We wouldn't be moving at all. We'd be surfing on a faster-than-light tidal wave of reality itself. If you looked at us on the outside, the light would bend so fiercely you'd see two ghost images of our ship, one moving forward and one moving backward in time. From the inside, half the universe would simply vanish from existence, as the light behind us could never catch up. Warp drives remain a distant mathematical dream, requiring energy that might not even exist in our reality. But the science shows us that our universe is far more bizarre, flexible, and terrifying than our human brains were ever meant to comprehend. You can cheat time, you can shrink space, and you can outlive your entire civilization. But no matter how fast you run, you will only ever arrive precisely when the universe allows you to. So, imagine strapping yourself into the ultimate machine.